Hello, everyone. Welcome to this webinar about Control, a tool that Armo has developed for detecting and trying out uh, cloud security products and having you also enabling you also to learn about modern cloud attacks. So welcome, everyone. Uh, Let me do like go over the short schedule. We might not use up the whole hour, though, depending on the Q&A and how we'll see the activity, we'll see if we'll have, we'll use more time. So I'm going to introduce the control suite for you. This is the main subject of the webinar today. And then I'm going to do a live demonstration of how to use it, both installation and running attacks over it. But I really encourage you at the end to engage me with questions because this is a live project that we started and I'm really happy about getting some feedbacks and questions. So I really want this to be interactive at the end, and also during the presentation and the demo, I'll be happy to getting questions. So please feel free to post any questions. So with all that, let me jump into why are we here today. So most of you are security practitioners, and really, I think that there is no need to go deeper of why the cloud shift that has been happening for like 15 years, how is it affects the security between teams and how we need to address the changes. Um, Really, the focus is the way that attackers are trying to penetrate an environment have changed. They've been also have their resources has also changed. It's more easy for them also uh, uh, to spawn up a new machine to get a new IP as opposed to what we had like 15 or 20 years ago. And because of this, I think that since there was a big change in the attack landscape, not because that necessarily all of these attacks were new, but because simply just new parts of the chains were attacked. I think it is important to shift the focus, and this control package that we've prepared is really here to help you both to learn more about these kind of threats and enabling you to engage in a more hands-on learning experience around that. And as nonetheless a reason is also to test your security stack. So if you think that your cloud environment your Kubernetes environment is well protected. You have great prevention tools in place. You might have great detection tools in place. This is a way to test them whether they are really protecting your environment the way you think they are. So control is really an attack simulator. It's not, I wouldn't call it a piece of software. I wouldn't call it a documentation. I wouldn't call it maybe a set of cloud manifests or container images. It is all together. It is a suite that we prepared that also we are using ourselves. Um, and it is meant to test detection tools originally. The reason why we started internally to working on this because we thought that it is important to test out the different tools. Also here we at Armo are making I think one of the greatest, of not the greatest, cloud detection product around. Therefore, it was really important to lead this for us to lead this spearhead these efforts, and we have collected of applications that are vulnerable. We built a few of them ourselves in order to reproduce existing problems. We built around them manifests, scripts, and some documentation for you in order to be able to reproduce these kind of attacks. Uh, the way what we are showing to you today and the things that you can access today is only the beginning, and we expect to expand on this project as we are going forward. We have quite a few ideas. So even if you start to use it today, I really suggest to check back in a month or two as well, uh, um, about let me maybe you are missing my screen share. So sorry. Um, So we've been really missing some of these um, capabilities, and I really hope that when we'll be able to add a little bit more kind of attacks, we'll be able to show you more about this. Now I'm asking my co-moderators if the screen sharing is okay and you seeing my screen, because I want to make sure that everyone is seeing what I see. So while I'm getting feedback on this, let me also open the Q&A if there are like any questions. So while I'm getting feedback, so who's the target audience? The target audience is security enthusiasts, as myself, someone who's loved this field and been around for some time. I always like to create tools and things for fellow enthusiasts, but in general, these are for security engineering teams, researchers, uh, all the people who are around this industry and want to learn more and want to get deeper understanding and be able to test out his existing environment is really here to get some new I think good things from this tool. So what do you need to use? What do you need to have in order to use this suite? So we've been around Kubernetes security also for a while, and I think that one of the easiest thing to be in the cross-platform world to test out cloud native applications is really Kubernetes. So I think it's also something that is like rather easy to work with. So you will need the Kubernetes cluster. Also, you obviously will need to have a workstation that you can connect this cluster with, and you can see you can execute commands with kubectl with bash and execute the scripts. Obviously, you're going to need this package that we are publishing to you, and obviously a browser through it. You can see this. So right now, if you want to take and scan this QR code, you can scan it right now, but you can also find the details on the Armo website a little bit later. Okay, so what are the attack types that as of today Control is covering? So we have 4 applications today that Control is coming with that you can install in your environment. You can have 4 different kinds of attacks that you can try out. One of them is I think the most easiest is a command injection attack, which I'm going to demonstrate you today. We have also local file inclusion, application with local file inclusion vulnerability, which enables an attacker to access files on the target machine. initiate file reads and get back their values. We have a little bit more complicated application that enables a server-side request forgery attack. So an attacker can craft an input to this server that will eventually lead to read and HTTP request execution capabilities. And the fourth, but not and last but not least, is an application with an SQL injection vulnerability, which is a little bit more complicated. So these are four attack types. The reason why we've started with these four is because we think that although there might be other attack types that will also be prevalent, but these are very easy to start with. And as I told you before, we'll develop this attack suite further to include more attacks that you can play with in your environment. So, okay, we are after the initial introduction. Let's go into demo mode, and I'm going to show you around how to work with this environment. And this is the reason why all of us got here today. So, so when you contact us and get access to control, you will get access to this documentation. In this documentation, you can follow installation guide that you can see how to install the control lab, and you can execute attack scenarios with all the explanation for each of the attack scenarios. So the first thing that we'll start with today is actually the installation. So as I told you before, the first thing that you're going to need a Kubernetes cluster. So in my, I'm using a Linux machine. So for me, it's super easy to spawn up a Kind cluster. So let's do that. So while it comes up, so in general, you can use any kind of Kubernetes clusters where you have administrative access to it. You can open port forwards, you can open execute into pods, or where you can bring up your own workloads. Obviously, I'm a word of advice: you shouldn't run obviously these kinds of applications in a live environment where is sensitive data or customer data. It should be run somewhere where you can test out in lab environment things. So when you download the zip file from the documentation I've shown you, you will get to this the directory tree where you will see the different files and directories that are included. One of them is this Kubernetes directory that includes all the installation manifests. But you will find also here the different attacks that are included in the current version of the suite. So let's go into the Kubernetes directory. And within the Kubernetes directory, you will see a YAML file, which includes all these four applications I've been talking about today, and all the things that we need. But we created a convenient script here called deploy sh that you can run by yourself, and it sets up the namespace and sets up in Kubernetes, so it will be really easy to remove the applications that we're installing now in your environment later on. And here we are creating a separation between these applications and others. So I really suggest running it. So what's happening right now when we run the script is that we are checking whether you indeed have a kubectl installed, whether you have a Kubernetes cluster connected. Then we are creating a namespace called attack suite in your Kubernetes cluster. Then we are deploying the vulnerable applications, all four of them. So in theory, you could decompose this YAML file, take out, if you want to check each application alone, you could, separate this YAML file into smaller YAML files that with each of these applications. But for the convenience and setup, what we did is actually bringing up all the four. So we are deploying all these applications with all the role bindings and things that we need for them. Then we're checking in the script whether all these pods have started. And when all of them are ready, then we are exiting the script. We are just showing, what are the status of the pods, what are the status of the connected services, and then a little explanation of what's been installed and what are the next steps. So again, just a little bit to go over of what you see here, what's been installed. So let me go into the namespace. So within the attack suite, you will see, these different applications that been installed. I can show you them over. Let me go over. I want to show you them in a visual, more visual way. While this comes up, let me show you. So these are the four applications. These four applications, if you go inside, you can look at each of those, what they are doing. In this case, we've installed this change detection deployment application, which is actually a news aggregator, vulnerable news aggregator application. You can see it's already talking with an external endpoint. You can see that there is the service that we've installed. It is actually, if you look inside, it's a Python application, and all four of those can be exploited. Also, the Spring Up, which is going to be the command injection application, the secure Python app, which is another Python application through which we are going to, you can try out the attacks on, including LFI and, if I remember correctly, also the SQL injection attack, and also obviously MySQL installation for, showing you how the SQL injection will work in this demo. So getting back to the cluster. So this was the whole installation process. It should work out of the way, and you should have this application after you run the shell script. Again, we are opening up all the options for you. So in theory, you can read the YAML file yourself. You can start to customize them the way you want. But let's start first of all with the command injection attack that I wanted to show you. So we have this ping application that was on the screen a second ago. And this application can be accessed via a port forward that we are going to start here. So for convenience, I've already printing here out the actual port forward that you need to use. So we're doing a simple kubectl port forward. We are not opening these applications up outside the Kubernetes cluster, and we are using port forwards because obviously there are concerns that if you're installing it somewhere where you are opening this service up to access from the outside world, obviously you will really fastly find attackers that are exploiting them. So this is why we are using port forward in general. So I've opened the port forward, and now I can access the application just as I've written here. I can access it through my local host. So let's open it up. And you are finding this cute ping tool application. this application is, again, this is something that we've built in order to showcase command injection style attacks. So in this case, what I'm going to do is application is meant to enable you to just ping an outside IP address. So let's ping the DNS server of Google. I'm clicking ping here. And yeah, I get the results. This IP answers, which is awesome. But there is a vulnerability here. And if you are coming into attack scenarios and go to the command injection page, you will see, you can read and you can see an explanation about what's happening here really, because it's a PHP application, and this PHP application has an implanted vulnerability. So as you can see within the PHP code, we are reading the IP address from this get parameter from the post. And this IP then is actually concatenated into a ping command that is being executed on the server side. You can see that ping minus C1 and the IP address. Now it looks, for someone who doesn't know this world, it doesn't look like anything, unusual. But anyone who understands the problem of injection attacks and right away understands that this string that we are reading here can include more than just an IP address. There is no input verification sanitization here. No one verifies that this string that we are getting here is really only an IP address and nothing else. So therefore, this piece of code, which is actually within this application that I've just shown you, is prone to a command injection vulnerability. So the way we are giving here examples of how this vulnerability can be exploited. So let's take a very simple example. So again, I'm trying to ping the IP address, then I'm using the semicolon to separate the IP address from a command. Then let's see what do we have in the root, in the current file directory. So if I'm running this command, you will see that after the ping command was executed, we are seeing that there is another output, which is actually the output of the ls-la, the directory listing command. So we've been able to inject a command within the query param here that you see. So this is what I meant by this deliberately vulnerable application. So in this case, you could go and check your detection tools, whether they are able to detect this kind of attack, or you can try to see whether you have I don't know, you're using different kinds of hardening tools in your environment that are preventing this command injection attack. But let's try to do something a little bit more interesting than just directory listing. Let's try to take the Kubernetes service account token from this container. So what we are going to do now is we are not just pinging, but we are using cat, executing cat to read this Kubernetes service account token, which is the credential through which Kubernetes API validates callers and entities. So let's run it. Yes, and what you can see here that again, after the ping process that executed here, we're seeing this strange string, which is, if I'm not mistaken, this is the JWT. So if I'm going to go to JWT.io, then you can see that this JWT is parsed, and actually this is the ping up pod service account token that been able to extract, and it is an identity called system service account attack suit default, which is the default service account token of this namespace. And we were able to extract. Now, in this case, the question is again, if there is such an attack, there is like how is we are being protected, whether you know why the service account token is mounted here, whether the command injection was detected. So in our case, an incident would be here something around credential detection attempts by cat. So in our case, you would see that there is an Apache process that was spawned from shell. This Apache is the PHP web server. And let's see here. And you can see here that this cat that was spawned from the same bash command that you've seen before by pinging 8.8.8.8, you can see the cut to the service account token, and you can see the detection that this actual file was taken. So a proper detection tool would surface this issue, and you would see that the service account token is being extracted from your environment. Now, again, it's a question whether a service account token should be touched by from within the pod or not, but or whether the actual command injection payload is detected. Uh, Obviously, all these things are questions to what kind of detection tools you are using, or the way that the rules are working on your existing detection tools. So this is the first kind of attack. Since we are only half time right now, I will go in and will try to do another attack. So, by the way, before I'm going forward, there are if you're going within the attack suite, you will see these folders. In the command injection folder, you will see this attacks sh, which is actually execute these attacks. And if I'm going inside, you will see that through command line, it extracts the same payload. So you can automate this kind of test and see what's happening and run it, automatically without using your browser itself. So again, this is for your convenience and depending how you want to do these tests. So let's go over to the other service I wanted to test, which is the actual server-side request forgery attack. Which was this one, the secure Python app. So again, let's try to open this application. Yeah, I'm not opened the right application. It's my bad. Give me a sec. Let's open the other one. It was the change detection app, sorry. No, not even that. So sorry for the mix up. So if we want to execute the server-side request forgery attack, so what we can do, we go to the actual explanation, And here you see that actually, again, we are explaining the actual problem with this application. What is the problem? And then what you can do, you can initiate a request to, in this case, for example, to google.com. We are through this helper PHP uh, endpoint. So let's try it out. Yeah. So what you can see here is that we've used this query parameter fetch, and we put there a URL, and this application pulled in that URL and returned it to the browser. In this case, you can target different endpoints. You will see here a few interesting endpoints. In case of, for example, I put here an option to test out whether you have AWS metadata service enabled for your Kubernetes node. So if you're installing this on your EKS environment or in AWS in general, you could try to target an interesting internal endpoint, which is the metadata endpoint of AWS. This is something that is there was a famous attack a few years ago back with the server-side request forgery vulnerability when the Capital One servers were hit exactly because of this kind of vulnerability, and the attackers were targeting actually this endpoint. So through the vulnerable application, they were able to query internal AWS endpoints, and they were able to retrieve credentials from those endpoints. So in this case, I'm not running in AWS, so therefore I cannot show you in this exact endpoint, but I tried to pull in the Google endpoint, and you can see that it showed me up here in my browser. So again, the question is now how it is showing in how it would look like in the detection environment. So yeah, there is I see that there is a server-side request forgery payload detected. So in this case, here is our secure Python app, which we ran, and here is the actual payload. Let me go down. You can see that here is the fetch request to http google.com. So in this case, either a detection tool would detect that there is a suspicious egress happening, or depending on what the attacker is targeting in the environment. Here are for every attack, we are listing for different um, different detection points, which I think it's interesting for you, and I will be very happy to get feedback on this. Okay, where we are expecting a detection tools to respond to that, whether there is an unusual outbound connection, where is an unusual internal access, whether the metadata services access, whether someone is detecting a port scanning that this kind of vulnerability can be used for port scanning, and so on. So this is how we see like every attack in the control suite. So you can see not just we're bringing you scripts and applications to try out yourself, which you can yourself learn and read the scripts, read the applications, and then reproduce yourself and change the way you want. But we are also trying to show you where we are expecting detection tools to show you and tap into and alerting you on. Okay, so I would be really happy to get questions here on everything I've shown, or regarding uh, regarding the suit that you've seen. So I would really like to engage you as potential users on this. So if you're welcome use the Q&A option here and send us questions. Yeah. So James is asking, what do the detection rules look like? Can they be tuned? So again, control is not specifically built to do detection. It was built more to try out your detection tools. In case of what you've seen, the Armo CADR I've shown you detection in. Yes, they are the detection can be tuned. We are supporting as of from mid-December custom rules that you can write in CEL language. Since most of these detections, not all, but most of these detections are relying on eBPF in case of Armo, events from eBPF of different process and file access and network patterns. You can write your own detection rules based on this very simple language, or use your favorite AI tool, and you can try them out in the Armo system itself. Okay. So in case, well, so maybe someone will want to ask more questions, but um, you know, if you want to sign up for this and get access to this tool at this stage, please scan this QR code, and there you can leave your contacts, and then we'll get back to you and give an early access to this tool, and you can try out it in your environment. You can test it yourself, share it, work with your team on it. Again, we want to develop more this tool further. We'll be happy to get feedbacks on, how is it for you, how's it working for you, what would be the next thing that you would be look for. Again, this tool has two purposes. One is testing your existing protection systems. The second is educational, so to be able to teach you to learn more hands-on about attacks and how attacks are working and what are their mechanics. So again, we are want to bring in the next phase that we are developing already two more attacks. One is emulating a supply chain attack, that how it would look like in your environment. I know that most of you have read in the past month that there were like supply chain attacks were again starting to become very popular. And you've heard obviously about the NPM attacks on the NPM packages or Python packages that were in the past half year. So we're going to prepare attacks that are emulating these kinds of events. And we are also want to involve somehow create attacks that are more involving cloud APIs, so that the initial attacks that you've seen here in the containerized world, in the cloud application world, are moving into the cloud API world from here. And these are the two upcoming attacks that we are going to add within the next 2-3 weeks as a Christmas gift for you. Yeah, so I will wrap this up. So first of all, thank you for joining. Since this is our baby, this project, we are very happy that all of you that joined here. It is really meant for you to, to learn, to improve, to be better in the world, in this world. And we are really happy to that you've joined and looking forward for you to signing up, using it, and giving us feedback so we can improve it more. Thank you very much.